Yes, in this video we are going to discuss about the introduction about the 8086 microprocessor. So that this unit 1 is unit 1. I am going to start the unit 1, that is 8086 microprocessor. In short we can call MPMC microprocessor architecture. Introduction, I am going to give the introduction about the 8086 microprocessor. 8086 is a microprocessor. In the 1978, Intel came out with the processor that is called 8086 microprocessor. It is a 16-bit processor. First important point in the case of 8086 microprocessor, that is, it is a 16-bit processor. That means what? It is 16-bit processor. That means it can handle the data. It can handle the 16-bit of data in every instruction. For every instruction, it handles the 16-bit of data, so that it is named as a 16-bit processor. Nowadays, we have been getting the 32-bit processor, 64-bit processors also. But whereas 8086 microprocessor is a 16-bit microprocessor which can handle the data, that is 16-bit for every instruction. And again, it can have the 16-bit address bus. 16-bit address bus. The second important feature of the 8086 microprocessor is nothing but it has the 16-bit address bus. Address bus is nothing but a group of communication lines is named as bus. This 16-bit, sorry, not address bus, this is data bus. 16-bit data bus. That means what? For every time it can read the data, 16-bit of data from the memory, and it can write the 16-bit of data into the memory by making use of bus. Bus is nothing but a group of communication lines, and it is having the 20-bit address bus. It is having that 8086 microprocessor is having the 20-bit address bus. That means what? We have the 20-bit address bus. It is group of communication. By using 20-bit address bus, we can have the 2 power of 20 address lines, which is equals to 10,48,574 memory locations we can have. Each memory location is wide of 1 byte, so that in order to locate the 16-bit of data, we require to have the 2 locations. And this maximum capacity, we can equate this to 1 megahertz, so that the 8086 microprocessor maximum can accessible by the 1 megahertz memory. And these 3 are the very important features of 8086 microprocessor, and it has been fabricating by the Intel company, and it has been packaging by the dual in line package. Likewise, we can go with some of the features of 8086 microprocessor. And the 8086 microprocessor we have been getting in the form of integrated circuit. So that integrated circuit is nothing but very large number of transistors are integrated together into a single semiconductor wafer, that is a chip. So that is called the 8086 microprocessor integrated circuit. This 8086 microprocessor standalone cannot perform any function, so that the 8086 microprocessor has to be interfaced with some input output devices, then only it makes the function. Whenever the 8086 microprocessor is interfaced with the input output devices, that resultant system is named as microprocessor based system. That resultant device is named as microprocessor based system. Microprocessor based system, because the microprocessor standalone cannot perform the function, so that to get the function, to get some decision makings from the microprocessor has to be interfaced with some input output devices. When the microprocessor is interfaced with input output devices, and that system is named as microprocessor based system. As we discussed, the microprocessor is also named as processor, is also named as CPU, so that this processor is interfaced with input output devices, means this CPU can interface with some input output devices. That system is named as a microprocessor based system. Here I am going with the example of the microprocessor based system. Example for the microprocessor based system is a microcomputer. This is the best example for the microprocessor based system. This is microcomputer. All we know that microcomputer is nothing but it is a microcontroller only. Computer on a chip is nothing but it is a microcontroller only. The best example for the microprocessor based system is a microcomputer, and so that I am going with the microprocessor based system, that is microcontroller. When the microprocessor is interfaced with some input output devices, that system is named as microprocessor based system. Microprocessor is nothing but it is a CPU only. In the last class I have explained the internal parts of CPU, that internal parts of CPU that can have the ALU, arithmetic logic unit, and the next one it can have the register units, and next one it can have the control unit. This is nothing but it is the processor only. Processor is also named as CPU, that is central processing unit. It is the brain of the computer, and now it can be interfaced with some input output devices. To interface or to communicate with the processor, we require to have the communication lines, and the group of communication lines we can call it is a bus, so that it is called a system bus. System bus is a bidirectional one because it can give the data to the processor and it can retrieve the data from the processor, and this system bus is a bidirectional system bus. It is a bidirectional system bus, and by using this system bus, the processor can be communicated with the input output devices. And first one in the input output device, I am going with the input. From this I can give the binary information. Input must be in the form of binary. To convert into the analog form to the binary one, we can have the encoders, decoders, and here this is the input and this is input. We are giving this input to the system bus, and system bus will take this data into the processor, where this processor will fetch some instructions from the memory. Here we are having some external memory. As we discussed, the maximum accessible size of 8086 microprocessor, that is about 1 megahertz. One maximum size is about 1 megahertz, so that we can have this memory. Here we can have this memory. This is external memory. This can be random access memory, and this can be read only memories. Here from this we can only read the data. From here we can read and write the data, and this memory is not only used to store the data but also used to store some instructions with the 2 power of 20 memory locations, that is 10,48,574 memory location it can be accessed. So that here the functionality of the microprocessor based system, here by using the input, by using the input device, I am giving the input to the complete system, so that by using the system bus it has been taking that data into the processor. By fetching some instructions from the memory, the processor will process something on the given data, and after that it delivers the output. That output maybe we can visualize that output may be on the output device. That output device may be any display device, any monitor, any LED, and that may be any CRT also. Then here input, the best example for the input is keyboard, a pen drive, and like that we can give the input by making use of some external devices. And here this is a memory, it is a external memory, it is a storage device, and in this storage device we can store the data and we can store the instructions also. So complete microprocessor operation depends on 3 words. One is fetching the instructions, from the memory. After fetching the instruction, that decodes the instructions. The processor decodes the instruction. After that, it executes the instruction. After executing the instructions, that will give the output to the on the output device by using the system bus, where the system bus is a bidirectional one. These are three combinedly named as processing of a processor. Processing of a processor. So that the working principle of a microprocessor is very, very simple. Whenever it gets the input from the input device, it calls some instructions, it fetches some instructions from the memory, and based on that instructions, decodes that instructions, and it will perform some operations on the given input signal, and that performing some operations on the input signal is nothing but it is executing the instructions. After executing the instruction, we can get the output in the hardware device, that is external device. By using this complete phenomenon, we can easily understand the microprocessor based system. Yes, here these are some of the important features of 8086 microprocessor. 8086 microprocessor, as we discussed, it is a 16-bit microprocessor. It is a 16-bit processor, means it is designed to handle the 16-bit of data in a single instruction. Internally, this processor is having that arithmetic logic unit, some registers, and this some instructions, arithmetic logic unit, some registers, some instructions, all are designed to operate with the 16-bit of data, so that it is named as 16-bit processor. I hope I am clear that ALU, that is arithmetic logic units, where we can perform where the processor can perform arithmetic and logical operations, and the registers are used to store some data and instructions, and here also it is used to store some data and instruction. All the three are designed to operate with the 16-bit of data, so that it is named as 16-bit processor. Coming to the next one is the microprocessor 8086 microprocessor is having the 16-bit of data bus. 16-bit of data bus means in a single instruction it can read the 16-bit of data from the memory. It can read the 16-bit of data from the memory, or it can write the 16-bit of data into the memory, so that it is having the 16-bit of data bus. Coming to the next one is about it is having the 20-bit of address bus. 20-bit of address bus, that means what? It is having the 20-bit of address bus. Bus is nothing but group of communication lines, so that 2 power of 20 is equals to 10,48,574, which is equals to approximately equals to 1 megabyte. Earlier, sorry, I told that is megahertz. Now this is actually, it is a megabyte. So the maximum capacity accessed by the microprocessor 8086 microprocessor is about 1 megahertz, and it can have the 10,48,574 memory location. Each location can allocate with the data of 1 byte, so that to have the 16-bit of data, 2 memory locations can be used, so that it is 20-bit. It is having the 20-bit address lines, and in the processor we can have the 14 register. Each register is a 16-bit register. We are going to study all these 16-bit registers, that is 14 16-bit registers in detail in coming classes. And coming to the operating clock frequency of this complete microprocessor 8086 microprocessor, that is about 5 megahertz, so that it is very, very huge frequency, so that if the frequency is more, so that time required to complete some operations are very, very small, so that by having the more frequency, this processor speed will increases. And coming to the next feature of the 8086 microprocessor, this 8086 microprocessor can be operated in 2 modes, minimum mode and maximum mode. And here, if to perform any function or to take any decision, if only single processor is enough, then that is named as minimum mode of operation. That means no other coprocessor are required, so that it is named as minimum mode of operation. Along with the microprocessor, if other coprocessors are also required to perform any function, so that mode of operation is named as maximum mode mode. Generally coprocessor 8072 is a coprocessor. If along with the 8086 microprocessor, if some other coprocessor is there, then that is called maximum mode of operation. And we know that this complete microprocessor we have been getting in the form of integrated circuit. The operating voltage or on voltage of that particular biasing voltage of that particular IC is about plus 5 volts DC supply we require. With this we can close this session, and tomorrow's class we will discuss the architecture of the 8086 microprocessor. Thank you. ఇప్పుడు 30 వచ్చింది నిన్న పొద్దున్న 30 వచ్చింది. Good evening students, welcome back to microprocessor and microcontroller online classes. In this video I am going to discuss about the first unit, that is 8086 microprocessor architecture. And before going to discuss the architecture of 8086 microprocessor, and we are going to recall the things whatever we have discussed in the last class. In the last class we have discussed about some of the basic definitions, some of the functionalities, some of the basic differences between the microprocessor and microcontroller. In this video I am going to recall all those concepts, and after that we will see the architecture of 8086 microprocessor and historical background of 8086 microprocessor. The last class we have given the definition of the microprocessor. Microprocessor is nothing but it is a multi-purpose programmable logic device. The programmable logic device is nothing but it is a semiconductor device which can perform the function according to the user program. Here user program is nothing but the set of instructions given to the semiconductor device, so that based on those instructions that semiconductor device can perform the function. So basically microprocessor is a PLD like the CPLD, FPGA, PROM, PLA, PAL, like all these things. This microprocessor is also the PLD, and we can get this, we have been getting this microprocessor in the form of integrated circuit, so that PLD is nothing but it is an integrated circuit in where the more number of transistors were integrated together on a single chip to perform some specific functions, that is called integrated circuit. So that microprocessor is a multi-purpose programmable logic device which reads the instructions from the memory, and which accept the binary data from the input, and based on the given instruction that data will be processed, and after processing that data that delivers the required output. So that the microprocessor is not only perform the specific function, it also take the required decision, so that the microprocessor is a multi-purpose programmable logic device. The last class we have discussed. So microprocessor is also simply named as it is a processor only. Microprocessor is nothing new to the processor. Microprocessor is nothing but it is a processor, and generally in general terms the processor is also named as central processing unit, that is CPU. When we get the CPU, when we get the complete CPU on a chip, then that is named as a microprocessor. So that other name for the microprocessor is nothing but CPU on a chip is called microprocessor. So that whatever the CPU can perform the function, the same functions will be carried by the microprocessor or processor. So that we know the CPU functionality. CPU is nothing but central processing unit, which is the brain of the computer. According to the brain instructions, the remaining parts of the computer will perform the functions. In similar way microprocessor is also give the instructions to the remaining parts of the microprocessor. Remaining parts means the some input output devices will be interfaced with the microprocessor, so that microprocessor will give the instructions to those interface devices, so that based on those instructions that will perform the function. So that not only performing the function, microprocessor is also controls the data flow between the processor and the input output devices. It executes some instructions, and these are some of the functionality of the microprocessor. In general, we are having in the syllabus that particular microprocessor is 8086 microprocessor. microprocessor, and we are going to discuss this architecture and the functionality timing diagrams of 8086 microprocessor in entire first unit. So we are also discussed about the microcontroller. Microcontroller is referred nothing but it is considered as a computer only. It is considered as a computer where we can have the microprocessor and we can have the input output devices, we can have some memory that may be RAM and ROM, and we can have some counters, and all these were integrated together onto a single chip that is called microcontroller. Micro means small and controller is nothing but it is a device which is going to control the devices which are interfaced with this microcontroller, so that it is named as microcontroller. Microcontroller will perform some specific operations only. Here we are using the word specific, that means what? The microcontroller will have the relation between the input and output. Nowadays we have been getting the various versions, various range of microcontrollers in the market, and they have been fabricating by the various companies, so that microcontroller is nothing but it is a computer on chip only, and whereas microprocessor is nothing but it is a CPU on chip. Likewise, we can go with the comparison between the microprocessor and microcontroller. In this class, I am going to start the actual syllabus of your microprocessor and microcontroller.